Collinearity. Collinearity is proving that points lie on the same line. Now, when it's 2D coordinates, we can prove that they lie on the same line using gradients. However, when it's vectors, we need to use components. Okay? And what we are essentially showing is that F, G, and H lie on the same line. Now, to do that, we want to find vector FG and vector GH. Now, they may not always be the same distance between them, but that's where we will see that there may be a common factor in the components that we could then take outside and put outside the bracket like we did when we were multiplying by a scalar. Okay, so points F, G and H have the coordinates shown respectively. So F's the first one, G's the next one, then H. Show that F, G and H are collinear. That's how a question would be asked. So first thing we're going to do is find vector FG. And to find FG, we do G minus H, which is going to be 4, 4, 4 minus 6, 1, 5. And that will give me minus 2, 3, move you up, and minus 1. So that's my components of F and G. Okay. Then my next one that I wanted to work out is GH. So GH is H minus G this time, which is minus 2, 13, 1. Sorry, mine's is off the page. Minus 4, 4, 4. Because that's what G is. And that gives me this time for GH. What am I getting? Minus 2, 9, no, minus 2, what? Since when was minus 2, minus 4, minus 2? Come on, woman. Oh, that was huge. Minus 6, sorry. 3, well, right, what am I doing? 9, I'm looking at the answers to the other one. Minus 3. That's right. Now that all is in the 3 times table. So we can take out 3 as a common factor. We give you minus 2 times 3 is minus 6. 3 times 3 would be 9. And minus 1 times 3 would give me minus 3. So that's 3 lots of 2, 3 minus 1. Now 2, 3 minus 1 we already said was FG. So that means that GH is the same as 3 lots of FG. And that there is the bit that shows us that they're collinear. Okay, it means that GH is 3 times the size of FG, but it does mean that they are collinear. Okay, so that means that on our wee diagram, we would have FG here, and then we would do 3 lots of FG to make up GH. However, that is not the final bit to our collinearity. We need a wee statement. We need to explain our answer. So we say since, and we use that bit that we just worked out. Since 3FG, because I did that first, is equal to GH. Now, what does that tell me? That tells me that they're... Oh, that's different colours, purple. That tells me that they are parallel. Since that, then vectors FG and GH are parallel. Now, parallel, 1R, 2 L's, 1 L. Took me a long time to learn how to spell that word. Okay? Now, that doesn't answer my question though. I want collinear. What makes them collinear is the fact that they both contain the G coordinate. Okay? So with a common point of G, then points F, G and H are collinear. Now, it's a big sentence, but you need to get that right in order to have it. When you're marking this, okay, you need the comparison and the fact that the vectors are parallel. Then you need the common point and that the points are collinear. That's the two bits to this statement that are very important. Okay, now, one of the bits, actually, when we are writing our comparison, we could also say that FG is equal to a third GH. Now, I don't do it in that way, simply because if you ended up with, what am I doing here? Hang on, take the pen off. If you ended up on the wrong page, because you went up a page, okay? Say, for instance, I'm just adding on to the notes now. Such is life. Right, if I had down here, so if I ended up with, say, AB was equal to 3, 2, 1, 2, right? And then I had BC is equal to 4, 2, 1, 2. Okay? For me to do my comparison of that one, you could either say that 4 lots of AB is equal to 3 lots of BC, because that's how you would make them equal. You would times them by the opposite number. Or, now this is where you get some options. Some people would say that AB is equal to 4/3, because you're just bringing the 3 round, of BC. Yeah, because that would be 6, 3, 6. And that would be 8, 4, 8. No, wrong way round. That is the wrong way round. So this is what I mean. I don't like doing it the other way, because I get them round the wrong way. This, you need to think about this. So that would be the 3 BC. So I just do that, but it would be 3/4 of BC, because you have to remember to flip it upside down. Or you could say that it would be 4/3 AB is equal to BC. You would see them in always. I prefer just switching and cross multiplying. That's how I do it.